Hey everyone, it's Ashpreet, and today let's build a team of agents using the newly released GPT-4 model. We'll start by building a single agent by giving GPT-4 a set of tools. Then we'll extend that agent with a team of dedicated agents it can delegate tasks to. So when it needs to write and run Python scripts, it'll delegate a task to the Python agent. Similarly, we'll give it a research and investment agent. This is very close to the LLM OS, which we've been building. So you'll see a lot of similarities, but I wanted to demo the team of agents in action here as well. So let's get started. This is what the application looks like. I'll give you the code for this app. We are going to interact with our main driver agent. It can answer questions directly, use tools, or delegate tasks. So let's get started. So first we'll ask, who are you and what can you do? This way, we are interacting directly with our main agent. It's got a set of capabilities. It's got a bunch of assistants. We can give it a set of tasks. It's working very, very well with the GPT-4o model. Now let's ask something for which it needs to use a tool it has access to. Let's say, what's the NVIDIA stock price? It's got access to the Yahoo Finance tools. It'll pull that up directly. Fantastic. Now let's ask something for which it needs to delegate a task to another assistant. Or you know what? Before that, let's see how knowledge retrieval works. We'll take Sam Altman's blog post, give it to its knowledge base. And what you'll see is that we want this to have more knowledge than any of the other agents. So we want this to have a generic knowledge base which all agents can use. So let's ask, what did Sam Altman wish someone had told him? Yeah, typos, everything, it's all fine. It's going to search its knowledge base for that information, pick out that blog post, and answer that question. Fantastic. So we can see this agent of ours can run tools, answer questions directly, access its knowledge base. Now let's see if it can delegate a task to another agent in its team. So let's say write a report on the IBM HashiCorp acquisition. Typos, everything is all okay, because the advantage of using this driver assistant is that it'll format this neatly and send it to the other delegated to its team members in the right text. Okay, so while this is going on, let's see where the code for this application is. It's under the file.data repo. To customize it, fork and clone this repository. Then under the cookbook, you'll find it under the agents folder. After you've cloned this repo, open it up in the code editor of your choice, cookbook agents. I also have added some examples of very simple agents like the web search agent. The web search agent shows you how to build a very basic agent with Phi-Data. We call them assistants because I don't like the word agent. It feels like, it's an intelligence like FBI agent that I'm building. We don't want to get into that business. It's an assistant because it assists us with tasks. So for us, agents equal to assistants. So we're going to build an assistant, give it the LLM, the GPT-4o, give it a set of tools and ask questions. That's pretty much it. If you want to add financial knowledge to it, add the finance tools, and then it can run multiple tools at the same time. So it's that easy to build an assistant with Phi-Data, which has access to tools. Now let's see the more complex agent which we're building. So in this cookbook, as always, the app is the front end, which is the Streamlit application which is running. I'm going to let you go through this yourself. It is generic Python Streamlit code. The magic really happens in the agent file. The agent file is where we define our agent that is running. Now to run this agent, open the README. It's got step-by-step instructions, very similar to the LLM OS which we've been building. So you can copy that, check that video out and run this file. And you should get the application running. But I do want to talk about this agent. So this agent, as I mentioned, is a Phi-Data assistant. It uses the GPT-4o model. We give our assistant a description and instructions, which is just a way to write the system prompt. The instructions are added as a numbered list, which we found LLMs follow better. You find a better way. You're free to just use the system prompt directly. You're free to just add messages yourself even. It's up to you. But the way we are programming this assistant, we are saying you're a powerful AI agent called Optimus Prime V7. You have access to a set of tools and AI assistants at your disposal, very similar to the LLM OS, but focused on really using its team. So we say when the user sends a message, think and determine whether you want to use a tool, whether you want to search your knowledge, search the internet, or ask a clarified question or answer it yourself. The more powerful models like GPT-4 Turbo and GPT-4o are able to just use these instructions and interact with us in a very human-like manner. We don't need to tell them a lot. We can just say, these are the few things you have access to, go figure it out. And they do pretty well. We also add storage backed by Postgres, meaning all the runs that are happening are in this database. We add a knowledge base, which is just a vector DB. It can use for retrieval. Then we add a set of tools and give it a team. This is the fun bit. So I'm going to go up, scroll up for you and show you the tools that it has access to. So when we select the tools from the UI, it'll enable those tools here, add it to the list, which are then added to the assistant, along with a set of extra instructions. For example, if you're using the file tool, we tell the assistant you can use the read file tool to read a file. This steers it in that direction. Like if I'm saying what's in the README file, it'll call this tool. This gives the assistant extra information on how to achieve a task for the user. This is kind of sort of where programming for AI agents has led us. We write what it needs to do. We tell it, okay, use this tool for this task, and it follows that instruction pretty well, especially with the good models. Then we're going to give it some team members. We're going to give it a data analyst. PhiData comes with pre-built custom assistants as well. So we have a DuckDB assistant that is fantastic for data analysis. Give it a set of CSV files, Parquet files, JSON files, anything which DuckDB can process, and it'll use that information to analyze data and return results. Similarly, a Python assistant can write and run Python code. A research assistant will generate a research report. So when we ask right now, give me a report on IBM HashiCorp acquisition, it'll use the Exa tools, which is the Exa search, a fantastic search engine, to get all the results and answer that question for us. Finally, it also has an investment assistant. So if we want to ask questions like, hey, shall I invest in NVIDIA? It'll reach out to the investment assistant, generate a report for us, and then return the answer for us. So this way, we give our main AI agent a set of tools and team members to achieve tasks. Finally, when you run that, this is what it looks like. When we ask the question, now let's check, write a report on the IBM HashiCorp acquisition, delegated the task, ran the task for us, gave us details, wrote a very nice report for us, and gave us references as well. So that's it, folks. This was an introduction to building AI agents, a team of AI agents using GPT-4o. If you have any questions, drop by in the Discord, open a GitHub issue, and have a great day.